Hello everyone, welcome back all to another wonderful session of Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. So today we are going to start Surface Chemistry Unit 5 Class 12 NCERT. Okay, so you all know what is surface chemistry. So surface chemistry deals with many phenomena that occurs or happens at the surfaces or interfaces. So normally we represent surface or interface by a hyphen or slash. For example, if you want to express an interface between a solid and a gas, you can show it by first writing solid, then put a slash and then write gas. So because of complete miscibility, gases don't have any interface between them. And the bulk phase which we come across in surface chemistry, they are either pure compounds or solutions. And many important formulas like phenomena like corrosion, electrode process, heterogeneous catalysis, dissolution, crystallization, they are occur at interfaces. So this subject, surface chemistry, it finds many applications in industry, analytical work and daily life solution. So in order to achieve surface chemistry, we have to really have a clean surface, normally under very high vacuum of the order of 10 raised to minus 8 to 10 raised to minus 9 Pascal. So like that. So solid materials with such clean surfaces should be stored in vacuum. Otherwise what will happen? It will be covered by molecules of many major components like dioxygen and dinitrogen. So here what we are going to actually study is the important features of surface chemistry like adsorption, then catalysis, colloids, etc. So first we are going to start with adsorption. So what is adsorption? As we already saw that the molecular species can accumulate at the surface rather than in the bulk of the solid or liquid. That is called adsorption. So the molecule species or substance which will accumulate or concentrate at the surface is called adsorbate. Remember, that is called adsorbate, and the material on the surface where the adsorption takes place is called the adsorbent. So learn to distinguish between what is adsorbate and adsorbent. Okay, now what are the actions of adsorptions? So mainly in gases like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide. Suppose we take these gases in a vessel, closed vessel which has powdered charcoal in it, then what can you observe? You can see that the pressure of the gas will decrease. That is, the pressure of the gas which is inside the vessel will decrease. So why is that? Because the gas molecules, they will always be present at the surface of the charcoal. That means the gases are adsorbed at the surface. Now, I think you have a slight idea of what is meant by the term adsorbed. So, in a solution of organic dye like methylene blue and all that, so suppose we add some animal charcoal to it and then you shake the solution well. So, what can you notice? So, you can observe that the filtrate from blue turns to colorless. So, here the dye molecules also accumulate on the surface of the charcoal. That means they are adsorbed. Now the next scenario is, suppose an aqueous solution of raw sugar, if it is passed over beds of animal charcoal, then it becomes colorless because the coloring substances are always adsorbed by charcoal. So also the air becomes dry in presence of silica gel. You have seen that we add little silica gel to keep the moisture away and to keep the air dry because the water molecules are adsorbed on the surface of the gel. So here the process of removing adsorbed substance from a surface on which it is adsorbed, that process is called desorption. Okay, now we will have a detailed look at the difference between adsorption and absorption. So these two are entirely different terms. So you saw that in adsorption, on the surface only the substance is concentrated. And what does it mean? It doesn't go inside to the bulk of the substance. And what about in absorption? It is uniformly distributed throughout the bulk of the solid. Everywhere in the solid absorption takes place, but whereas adsorption takes place only in the surface of the substance. So you can distinguish between the two by taking water vapor as an example. So, water vapor normally is absorbed by anhydrous calcium chloride, but it can be adsorbed by silica gel. Okay, so in other words, how can you express it? That is, in adsorption, the adsorbate's concentration will increase only at the surface of the adsorbent, but in absorption it is uniform. The concentration is uniform throughout the bulk. So both these processes takes place simultaneously also. So we use the term sorption to describe both of these. Okay, now I think you have got a fair idea about what is meant by adsorption. What is the difference between adsorption and absorption? Now we will have a look into the mechanism of adsorption. So adsorption is why is it happening? It is happening due to the fact that the surface particles of the adsorbent, they are not in the same environment like the particles inside the substance. So inside, what happens is that all the forces acting between the particles are mutually balanced, but on the surface the particles are not surrounded by the atoms or molecules, because above the surface it's air. So but whereas in inside, everywhere the gas or whatever it is will be present, but on the surface, so it is not uniform. So there will be an unbalanced or residual attractive forces. So these forces of adsorption, they are responsible for attracting the adsorbate particles onto the surface. So the extent of the adsorption increases with the increase in surface area per unit mass of the adsorbent for a given temperature and pressure. So we can say that inside the adsorbent, the forces acting between the particles are mutually balanced, but on the surface the particles are not surrounded by the atoms, so they possess unbalanced or residual attractive forces. So these forces attract the adsorbate particles onto the surface. Okay, so the extent increases with the increase in surface area per unit mass at a given temperature and pressure. Now another important factor of adsorption is the heat of adsorption. So what happens during adsorption? Always there is a decrease in residual force of the surface, or there is a decrease in surface energy which is given out as heat. And adsorption is mainly an exothermic process. What is an exothermic process? Exothermic process where heat is released. Endothermic process is a process where heat energy is absorbed. So the delta H of adsorption is always negative, and when a gas is adsorbed, the movements of the molecules gets restricted, which results to the decrease in the entropy of the gas after adsorption. So therefore delta S is negative. So you can see that adsorption is normally accompanied by the decrease in enthalpy as well as decrease in entropy of the system. So in order to the spontaneity of the process, the thermodynamic requirement is mainly constant temperature and constant pressure. Then delta G must be negative, that is Gibbs energy is decreased. So we have got an equation like delta G is equal to delta H minus T delta S. Delta G can be negative if delta H has high negative values, because minus T delta S is positive. So in adsorption process, which is spontaneous, a combination of these two factors will make delta G negative. So delta H of adsorption is always negative when a gas is adsorbed, because as I said, the molecules doesn't have the freedom for movement, and so the entropy is decreased after adsorption. So adsorption is accompanied by decrease in enthalpy as well as decrease in entropy of the system. So as the adsorption proceeds, what will happen? Delta H will go on getting less and less negative, and finally delta H is equal to T delta S and delta G tends to 0. So at this state equilibrium is attained. So always you remember at what stage equilibrium is attained, that is the delta H becomes equal to T delta S, and then when delta G becomes 0, equilibrium is attained. So what are the types of adsorption? Mainly we have got two types of adsorptions of gases on solids. So suppose if gas accumulates on the surface of a solid because of weak van der Waals forces, the adsorption is called physical adsorption or physisorption. So when the gas molecules or atoms, they are held on to the solid surface by bonds, then the adsorption is called chemical adsorption or chemisorption. So physisorption and chemisorption. So chemical bonds are, as you already know, they are either ionic by giving or taking of electrons, or covalent, sharing of electrons. So chemisorption has actually high energy of activation, so it's often called as activated adsorption. So many a times these two processes will happen together at the same time, and we cannot say easily which type of adsorption is taking place. So a physical adsorption at low temperature may change into chemisorption as the temperature is increased, like dihydrogen is first adsorbed on nickel by van der Waals force, and also molecules of hydrogen will dissociate to form hydrogen atoms. Then by chemisorption they are held on to the surface. Now we will look into the characteristics of physisorption. So as you all know, this is a part of physical chemistry. This lesson is extremely important in the NEET point of view also, and also this is very pretty simple concepts. If you can have an easy quick revision with the content I am presenting for you, I have prepared for you, because the textbook, it is given in a very lengthy, but always as I have always said, reading of NCERT is very important, but for those children who are doing last minute revisions, this will come as quite handy and easy to just recollect all the concepts. So now we will move on to the characteristics of physisorption. So first point is lack of specificity. Because at a given surface normally the adsorbent doesn't show any preference for any particular gas because the van der Waals force are universal. Then what is the nature of adsorbate? And the solid, the amount of gas which a solid adsorbs mainly depends on the nature of the gas. Like if it is easily liquefiable gas, they are all very readily adsorbed because van der Waals forces are stronger near the critical temperatures. Then these physical adsorption of a gas by solid, it's reversible only. So more gas is adsorbed when the pressure is increased, because the volume of the gas decreases. Pressure and volume are inversely proportional. When the volume increases, the pressure decreases, and the gas can be removed when the pressure decreases. So the adsorption process is exothermic. The physical adsorption normally happens very readily at low temperature, and it decreases with increase in temperature according to Le-Chatelier's principle. So I have taken special care to include the most important points from the NCERT textbook. Most of the points are included here, with headings and easy. You can use it as notes also by taking the printout of this and keeping it as a file, and over each file you can write the name of the lesson as well. Then the fourth point is that the surface area of the adsorption. So adsorption's extent increases when the surface area increases. So finely divided metals and porous substances which has large surfaces are really good adsorbents. Then what is meant by the fifth point is enthalpy of adsorption. So we already said that physical adsorption is exothermic process, but its enthalpy is very low. Why? Because the attraction between gas molecules and surface of solid is only due to the weak van der Waals forces. Now we just had a revision of the characteristics of physisorption. Now what about the characteristics of chemisorption? So first one is high specificity. So chemisorption is highly specific, and when does it mainly occur? That is only if there is a possibility of chemical bonding between the adsorbent and adsorbate. First itself I mentioned what is adsorbent and adsorbate. Those who didn't notice it can go back and just repeat it again. Then irreversibility. So here it is irreversible because it involves compound formation which is irreversible in nature. And chemisorption is also exothermic process, but it's very slow at low temperature because of the high activation energy. Like most chemical changes, adsorption will increase with increase in temperature. Then physisorption of gas adsorbed at low temperature will change into chemisorption at high temperature. So usually high pressure is also favorable for chemisorption. So these points are all very simply mentioned here. Now surface area. Like physical adsorption, chemisorption also increases with increase in surface area. And enthalpy of adsorption, enthalpy is high because of involving of chemical bond formation. Now we can look at a table given here which mentions the difference between physical adsorption and chemical adsorption. So for physical absorption, forces operating are weak van der Waals forces. Then the other case, it is chemical bonds, ionic or maybe covalent. Then second point is heat of adsorption is low, and heat of adsorption is high for chemical adsorption. Then the third point for physical adsorption, irreversible process, and the other one is irreversible process. And here desorption can happen by increasing the temperature or decreasing the pressure. And here the fourth point is that it doesn't require, physical adsorption doesn't require activation energy, chemical adsorption requires activation energy. Then physical adsorption takes place at low temperature and decreases with increase in temperature, whereas chemical adsorption first increases with increase in temperature. Then physical adsorption, it's not specific in nature. All gases adsorbs on solids to the same extent, but whereas in chemical adsorption it is highly specific in nature and occurs only by the possibility of formation of chemical bonds. Then physical adsorption increases with increase in surface area, and chemical adsorption also increase with increase in surface area. Then physical adsorption forms multimolecular layer, whereas chemical adsorption forms unimolecular layer. Now what are adsorption isotherms? So the adsorption isotherms, this context is very much important in surface chemistry. So the variation in the amount of gas adsorbed by adsorbent with pressure at constant temperature is usually expressed by a means of curve called adsorption isotherm. So it was Fruitlands, normally known as Fruitlands adsorption isotherm. In 1909, he gave an empirical relationship between the quantity of gas adsorbed by unit mass of solid adsorbent and pressure at a particular temperature, and it's called, the relationship is normally expressed by the equation x by m is equal to k into p raised to 1 by n, where n is greater than 1 and x is the mass of the gas adsorbed on mass m of the adsorbent at pressure p. K and N are constants which depend on the nature of the adsorbent and the gas at a particular temperature. So this relationship we generally represent in the form of a curve, where mass of the gas adsorbed per gram of the adsorbent is plotted against pressure. The figure also is given in the textbook, and these curves, what do they show? That is, at fixed pressure, physical adsorption will decrease with the increase in temperature. So what is the speciality of the curve? They will always approach saturation at high pressure. So you can see here that the adsorption isotherm is plotted with x by m in the y-axis and p along the x-axis, pressure p along the x-axis, and the curves at a fixed pressure. You can see that a decrease in physical adsorption with increase in temperature. So you can see that 273 Kelvin with the high pressure, then the curve is shorter. So this is for your reference. Then you can take the log on both sides of the equation. You get like log x by m is equal to log k plus 1 by n log p. So the validity of the Fruitlands isotherm can be verified if you plot log x by m on y-axis, which is known as ordinate, and log p on the x-axis abscissa curve. Suppose if it is a straight line, then we can say that the Fruitlands isotherm is valid, otherwise it is not valid. And the slope of the straight line, it gives the value of 1 by n, and the intercept on y-axis will give the value of log k. You know, normally Fruitlands isotherm explains the behavior of adsorption in a highly approximate manner. So the factor 1 can have values between 0 and 1. So over a limited range of pressure, this equation holds good. So suppose if 1 by n is equal to 0 and x by m is equal to constant, then the adsorption is independent of the pressure. Suppose if 1 by n is equal to 1 and x by m is equal to k p, then that is x, it means x is directly proportional to p, then the adsorption directly varies with pressure. So the both conditions are supported by experimental results. So the experimental isotherms always seems to approach saturation at high pressure, as I already said, but this factor is not explained by Fruitlands isotherm, so it fails at high pressure. So this point is very important, just notice that. And already, as I said about surface chemistry, which deals with the phenomena occurring at the surfaces, and we also just had a quick look at what is meant by adsorption, which occurs at the surface more than in the bulk, and it actually involves accumulation of substance at the bulk, which is different from absorption. Absorption is accumulation of the substance in the bulk than in the surface, whereas adsorption happens at the surface. So always remember, adsorption happens at the surface and absorption happens at the bulk of the substance. So both of them occur simultaneously. So these already I have mentioned. And substance getting adsorbed is known as adsorbate, and the surface is called adsorbent. This is a surface phenomena, and solids should be finely divided as adsorbent. They should have a large surface area so that the process goes on well. And normally we use charcoal, silica gel, alumina gel, clay, colloids, metal in finely divided state as good adsorbent. So some of the examples of adsorption are adsorption of a gas by charcoal, we mentioned all this, adsorption of a dye by charcoal, purification of raw sugar, then removal of moisture from air. Then also we saw the difference between adsorption and absorption. So adsorption, it's absorption. We are looking first at absorption, which occurs in the bulk and it is uniformly distributed throughout the body, whereas adsorption is occurring at high concentration and at the surface rather than in the bulk. And absorption, whereas it is occurring uniformly. Adsorption is very fast at the beginning and then it slowly decreases. For example of absorption is anhydrous calcium chloride, it absorbs water, whereas in adsorption silica gel absorbs water vapor. So we also just went through the mechanism of adsorption, that the surface particles of adsorbent, they are not in the same environment as the particles inside the bulk, and inside the adsorbent the forces acting are mutually balanced, because you know these are all surrounded by the atoms or molecules around it, but because adsorption is a surface formula and it's not surrounded, the particles are not surrounded by atoms or molecules on all sides, it's not it's unbalanced, not balanced. Then the forces of adsorbent are responsible for attracting the adsorbed particles on its surface, and the adsorption rate increases with increase in surface area per unit mass of the adsorbent at a given temperature and pressure. Then we went through Fruitlands adsorption isotherm, and we have got two different graphs here. One is the first one is pressure along the x-axis and x by m, extent of adsorption along the y-axis. So you can see the curve here and the various values of the graph, and also along the second graph which shows log p on the x-axis and log x by m along the y-axis. You can see the slope 1 by n, and also the isotherm explains the behavior of adsorption in an appropriate manner. And as I already said that the factor 1 by n can have values between 0 and 1. Probable ranges from 0.1 to 0.5. So these are all representations, and when 1 by n is equal to 0, x by m is equal to constant, I already have explained all those things. And with that we are coming to the end of the first part of surface chemistry, and as I already said, since this is a big topic, I have divided it into 5 parts, and today we have finished the first part, and I will be uploading the second part as early as possible. And the most important thing I would like to mention to you all here is you have to be always thorough with NCERT, because the base for NEET preparation is considered to be NCERT textbooks. Frequent revisions of NCERT textbooks of physics, biology and chemistry is found to be an efficient method for better recollection of concepts. So always you keep that in mind, and as I always say, please like, share and subscribe to my channel, and click on to the bell button so that you will get notifications as soon as I come up with new videos. And already, as you know, Tamil Nadu State Counselling is going to take place online for the first time in the history of Tamil Nadu this year, and wishing all the best for the NEET aspirants for the 2021 batch. So with that, we are coming to a conclusion of this session. So thanks for watching, and until I come up with the next video, thank you all. Welcome back everyone to another wonderful session of Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. In our last session, if you remember, we had started Surface Chemistry Unit 5, Class 12, and we had discussed about adsorption, absorption and the differences between these two, Fruitlands isotherm and all that. Hope you have all revised those topics and understood the concepts well. And today in the second part we will be continuing with the applications of adsorption and the remaining parts of the important concepts of this unit. So then we will first move on to the applications of adsorption. And so what are the different applications? As you can see that it is used in gas masks and in coal mines. What is a gas mask? It is a device which has activated charcoal or mixture of adsorbents, and usually it is used for breathing in coal mines to adsorb poisonous gases. Then the process is used to control humidity, because silica and aluminum gels are used as adsorbents for removing moisture and controlling humidity. Then it is also used in the production of high vacuum, that is the remaining traces of air is adsorbed by charcoal from a vessel evacuated by a vacuum pump to give a very high vacuum. And removal of coloring matter from solution is another important application. For example, animal charcoal removes colors of solutions by adsorbing colored impurities. Then we have got heterogeneous catalysis, that is adsorption of reactants on solid surface of catalyst increases the rates of reaction. So many gaseous reactions of industrial importance which involves solid catalyst happens, for example in the manufacture of ammonia using iron as catalyst, and also then the manufacture of sulfuric acid by contact process and all. Finally, divided nickel catalyst is used, and in the hydrogenation of oils. These are all excellent examples of heterogeneous catalysis. Then another application you can see is in the separation of inert gases, because due to the difference in adsorption degree of gases by charcoal, noble gas mixture is separated normally by adsorption on coconut charcoal at different temperatures. Then in curing various diseases, like number of drugs are used to kill germs by getting adsorbed on them. Then another important process is froth flotation, which is in this process a low grade sulfide ore which is concentrated by separating it from silica and other earthy matter by using pine oil and frothing agent and all that. Then we have got that adsorption indicators, like in certain precipitates of silver halides and all that, the surfaces have the property to adsorb some dyes like eosin, fluorescein, etc. And it produces a characteristic color at the end point. Then chromatographic analysis, which is based on the phenomena of adsorption, it finds a lot of application in analytical and industrial fields. So just remember all these important applications of adsorption. Now we will see about the adsorption from a solution phase. We have learned, first of all, we learned about what is adsorption. This is a process which happens on the surface of the substance and not inside the bulk, and it is unbalanced. All these things we already studied. Now we will learn about adsorption from solution phase. So solids can adsorb solutes from solutions as well. So if you take a solution of acetic acid in acetic acid, then you take some charcoal, then shake it well. So what happens is that it is absorbed by charcoal and the concentration of the acid will decrease in the solution. So what happens in the case of adsorption from a solution phase is that the first extent of adsorption, it is seen to decrease when the temperature increases. That is the first point. Second point is that adsorption rate will increase when the surface area of the adsorbent increases. Then the third point is that the extent of adsorption, it depends on the factor of the concentration of solute in solution, and also on the nature of the adsorbent and the adsorbate. And also Fruitlands equation, approximately what does it describe? The behavior of adsorption from a solution, with a difference that instead of pressure, concentration of the solution is taken into account. So we don't take the pressure, but instead of pressure, concentration is taken into the account. So you can see here in the equation that x by m is equal to K into C raised to 1 by n. So, C is the equilibrium constant and equilibrium concentration, and the adsorption is complete. So, what you have to do, the next step is to take the logarithm of the both sides of the equation. So, we got the equation like x by m is equal to k into C raised to 1 by n. C is the equilibrium constant. So, when the adsorption is complete, we are taking the logarithm on each side to get log x by m is equal to log k plus 1 by n log C. So, what we do is we plot a graph like log x by m against log C, get a straight line which shows the validity of the Fruitlands isotherm. So, you can also test this factor experimentally by taking solutions of different concentrations of acetic acid, then equal volumes of solutions when added to equal amounts of charcoal kept in different flasks. So, you have to determine the final concentration in each flask after adsorption happens. So, what happens is that the difference in the initial and final concentration will give you the value of x. So, with the equation which is shown here, then validity of the Fruitlands isotherm can be finally determined. So, that is one important concept. So, you have to know about the equation of adsorption from solution phase, and because solid adsorbs solutes from solutions. So, from that we arrive at a conclusion of finding out the amount of extent of adsorption and finding out whether Fruitlands isotherms validity can be established. And next we are looking at the applications of adsorption, and also as I mentioned earlier, again production of, because I am repeating some of the important concepts again so that you can retain it well in your mind. Production of high vacuum, as you already know that the traces of air, it is absorbed by charcoal. It should happen in an evacuated pump, which is where we use a vacuum pump to establish a very high vacuum. Only then the traces of air can be adsorbed. And the gas mask used for breathing in coal mines to adsorb poisonous gases, then controlling humidity using silica and aluminum gels to remove the excess of moisture and control humidity. And also all these processes I have already explained, but for your convenience I am giving the reasons also. Removal of coloring matter from solutions, and also here also adsorption is the concept taking place. Heterogeneous catalysis, adsorption of reactants on solid surface which increases the reaction rate, and also separation of inert gases can be separated by the technique of adsorption, curing large number of diseases by using drugs and getting it adsorbed on the germs are killed by getting them adsorbed on the drugs. Then froth flotation process, sulfide ore concentrated by separating it from silica and other earthy matter using pine alloy and frothing agent. Adsorption indicators, certain precipitates like silver halides which have the property of adsorbing dyes like eosin, fluorescein, etc., and producing a characteristic color by which we are able to distinguish them. And then chromatographic analysis, it's based on the phenomena of adsorption, finds many applications in analytical and industrial fields, which is shown in the form of a chart here. It's not very clear. And the next we learn about what is meant by catalysis. So here it's nothing. For one example, if you take little potassium chloride, that is KClO3, you heat it strongly. What happens is that KClO3, it decomposes and gives you KCl, potassium chloride and oxygen. So normally the temperature at which the decomposition occurs ranges from between 653 to 873 Kelvin. But if you add a little amount of manganese dioxide to it, this decomposition takes place at a lower temperature range, that is 653, 873 range has come down to 473, 633, and also you can see that the reaction is taking place at much faster pace. So why this is happening? Because as you already saw that we had added a little bit of manganese dioxide, and the added manganese dioxide remains unchanged. It doesn't change with respect to mass or composition, but it only accelerates or helps the reaction speed up and go to completion. How does it do that? It lowers the temperature range. So it is easily achievable and helping the reaction to get into completion. You see, in this way the number of so many chemical reactions can be altered by just adding a little bit of foreign substance. The substance doesn't undergo any change as of itself, but helps the reaction to get into faster completion. Then what are promoters and poisons? Promoters, these are substances which can improve the activity of a catalyst, but poisons will decrease the activity of a catalyst. In Haber's process in manufacturing of ammonia, you add molybdenum as a promoter for iron, which is used as a catalyst. So along with iron you can add molybdenum as a promoter, so it helps the reaction to go to completion soon. And homogeneous and heterogeneous catalysis. What is meant by homogeneous catalysis? So if the reactants and the added catalyst are in the same phase, that is if it is liquid or gas, whatever it is, we say that the process is said to be homogeneous. So some of the examples are given here. Oxidation of sulfur dioxide to sulfur trioxide by adding oxygen in presence of oxides of nitrogen as catalyst in lead chamber process. That is one example. Here the reactants are sulfur dioxide and oxygen. Nitric oxide is the catalyst, and these are all in the same phase. All these are gases, as you can see in the equation. Then hydrolysis of methyl acetate is catalyzed by H plus ions. Where do you get this H plus ions? It is obtained from hydrochloric acid. So CH3COO, CH3, liquid phase, H2O, that is also liquid. You get the product CH3COO, that is also aqueous, and CH3OH in presence of HCl. And hydrolysis of sugar also, it is also catalyzed by H plus ions, which is given by sulfuric acid. You get glucose and fructose, which is also in the solution phase. So what is heterogeneous catalysis? So in presence of platinum, sulfur dioxide is oxidized to sulfur trioxide. So the reactant is in the gaseous state, but you can see that the catalyst is solid here. And then the combination between nitrogen and hydrogen to give ammonia. In the presence of finely divided iron catalyst, that is gas, reactants are in the gaseous state, but the catalyst is in the solid state. Iron is in solid state. Iron is the catalyst, that is in the solid state, but the reactants nitrogen and hydrogen are in the gaseous state. And then what happens is that the next example you can see here, they can give you examples and ask whether it is heterogeneous catalysis or homogeneous. You will be asked to identify. Then ammonia NH3, it reacts with oxygen in presence of platinum catalyst to give NO, nitric oxide, and water. So reactants as in the earlier cases gaseous state, and while the catalyst is in the solid state. And the hydrogenation of vegetable oils, so that also occurs in the presence of finely divided nickel catalyst. Reactants in the liquid state, and catalyst is in the one reactant, that is vegetable oil, is in the liquid state, whereas the second reactant, hydrogen, is in the gaseous state, and the catalyst here is in the solid state. You get the product vegetable ghee. So I hope you clearly understand what is meant by homogeneous catalysis and heterogeneous catalysis. Now what is the adsorption theory of heterogeneous catalysis? So here from this theory which explains the mechanism of heterogeneous catalysis. So this is known as the adsorption theory of catalysis. Here what happens is that if the reactants is in gaseous state or in solutions which are adsorbed on the surface of the catalyst. Catalyst is in the solid state, remember, these are not in the same phase. This is heterogeneous catalyst. So the catalyst is in the solid phase, and what happens is that the concentration of the reactants on the surface of the catalyst will increase slowly, and also it increases the reaction rate. So adsorption, it's an exothermic process. So the heat released by this exothermic process, we can use it to improve or speed up the rate of the reaction. So I hope you understood this theory well, and with that we come to the end of the second part as well. And also as always I say, in this context, the next important thing we have to remember is the resolution of doubts. It is only when you revise certain concepts you will get into thinking deeper about the subject, and most often you end up with a variety of questions like to which you may not be able to find an answer. So in such cases, do not hesitate to seek some help from your teachers or friends, and don't pile up your doubts. it's a must to get all your doubts cleared from the previous concept before moving on to a new concept. So this point all of you keep in mind, and also we'll come up with the next session, that is part 3 at the earliest. I'll be uploading the next part as well. As you all know, this is a very important topic from surface chemistry of class 12, which is equally important for your board exams as well as NEET point of view also. And another thing is that for whichever lessons where we have problems, I'll be uploading a separate video solving all the important problems, and in a very easy way, including the calculations, making simple, because for NEET exam you never get much time to solve a single question. You shouldn't be taking more than a few, like 45 seconds or 60 seconds or less than 1 minute will be all you are getting for solving a sum. So if the calculations are so much of type of lengthy and all that, and if you take so much of time in solving just one sum in physics and chemistry and all that, you will be wasting lots of time and you won't be able to answer most of the questions quickly. So I'll be helping you out with the problem side as well. Then I'll be uploading mind map or notes after each lesson, and coming up with objective questions, then doing simple tricks for many lessons from wherever tricks are applicable. I'll be uploading that also. And don't forget to share all these videos with your friends, and do like and subscribe to my channel. And thanks for watching this video until I come up with the next one. And with that we are winding up for today. Thank you. Welcome back everyone to another wonderful session of Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. So as you all know, we already have finished 2 parts of Surface Chemistry Unit 5 from class 12, which is a very important lesson in the view examination point of view for board exam as well as for NEET exam. So already we have studied many concepts from surface chemistry, including adsorption. We studied what is meant by adsorption and distinction between adsorption and absorption, the mechanism of adsorption and the different types of adsorption, and we learned about the adsorption isotherms and Fruitlands adsorption isotherms and all that. Then we also learned what is adsorption from solution phase and different applications of adsorption. We studied about catalysis, then homogeneous and heterogeneous catalysis, then the adsorption theory of heterogeneous catalyst. And today we will be continuing with the some important concepts. So all of you, those who haven't watched the previous session, can go back and continue from the first part only, then you will be able to follow the concepts well. So firstly, we were talking about the adsorption theory of heterogeneous catalysis. So what is this theory actually? This theory explains the mechanism of heterogeneous catalysis. So the old theory known as adsorption theory of catalysis was that the reactants in gaseous states or in solutions are adsorbed on the surface of the solid catalyst. So the increase in concentration of the reactants on the surface will increase the reaction rate as well. As you all know, adsorption is an exothermic process, and the heat of the adsorption is used to improve the reaction rate. So the catalytic action can be explained in the terms of intermediate compound formation. That is a theory of which you have already studied in some previous session. And the modern adsorption theory, it is a combination of intermediate compound formation theory and the old adsorption theory, and the catalytic activity is mainly localized on the surface of the catalyst. So we can see that the mechanism has got 5 important steps. So we are going to briefly go through the important steps. The first step is diffusion of reactants to the catalyst surface. So the reactants are diffused to the surface of the catalyst, first step. Then adsorption of the reactants again to the surface of the catalyst, and after that chemical reaction occurs on the catalyst surface by the formation of an intermediate. And after the reaction occurs, the desorption of reactant products from the surface of the catalyst. What happens because of this? It makes the surface again available for more reaction to occur, because this is a continuous process. So in order to the process to get continued, more space should be made available for more reaction to occur. So for that, desorption of reaction products should take place from the surface of the catalyst. So once that is over, fifth step is diffusion of the reaction products away from the catalyst surface. That is, surface of the catalyst, no, it's not like inside the bulb. The surface has free valencies, because of which there occurs the chemical forces of attraction. So you can see that whenever a gas molecule will come near the surface, the molecules will be held there by loose chemical combination. So if different molecules, if these are adsorbed side by side, then they will react with each other, and as a result new molecules are formed. These molecules will evaporate, then leave the surface, making space available for fresh reactant molecules. So this is very easy. If you just focus on the points and concentrate well, even if you read it one time, you will never forget this concept. Okay, so now we will move on to solid catalysts. So there we have got to study about different important features of the solid catalyst. The first one being activity. So the activity of the catalyst mainly depends on the chemisorption. That is, the reactants must get adsorbed strongly to the surface of the catalyst to become active, but they should not be adsorbed very strongly as well, because if they are adsorbed strongly, they will be sort of not able to move, immobile. So because of that, the other reactants will get no space on the surface of the catalyst for adsorption. So for hydrogenation reaction, it is seen that the catalytic activity increases from group 5 to group 11 metals. Maximum activity is shown by group 7 to 9 elements on the periodic table. So 2H2 plus O2 gives 2H2O. Then the next point is, important feature is the selectivity. So what is meant by selectivity of a catalyst? It is the ability to direct a particular reaction in such a way that you get a selective product or a particular product, but under the same conditions, if the reaction occurs, many other products are also possible. So selectivity of catalyst is very important, because for same reactants, the selectivity of different catalysts will be different. That is, starting with H2 and CO. If you use different catalysts, we get different products, like example methanol, methanol and all that. So the catalyst is very highly selective in nature. So a substance which acts as a catalyst in one reaction, if you use the same catalyst for another reaction, it may fail to yield that particular product. So you have to select the catalyst according to whatever product you want, particular product you want. So that the selection of catalyst is very important. And the shape selective catalyst by zeolites. So that is another important concern. The catalytic reaction, which mainly depends on the pore structure of the catalyst and also the size of the reactant and product molecule, is called shape selective catalysis. So zeolites are good shape selective catalysts, because you have seen their shape. It looks like honeycomb structures they have got, and the honeycomb structure also, and they are microporous aluminosilicates with 3D network of silicates, in which some silicon atoms are replaced by aluminium atoms. So in that way they are giving like aluminium, oxygen, silicon, like that the framework is taking place. So the reaction taking place in zeolites mainly depends on the shape and size of the reactants and the product molecule also, and also upon the pores and cavities of the zeolites. So normally they are found in nature as well as synthesized for catalytic selectivity, and widely these are used in petroleum industries for cracking of hydrocarbons. And also an important zeolite catalyst used in the petroleum industry is Isodersum-5, which converts alcohols directly into petrol by dehydrating them to give a mixture of hydrocarbons. So what are the characteristics of enzyme catalysis? First one, it is highly efficient. Second is highly specific. Then highly active even under optimum temperature. Then highly active under optimum pH. Then increasing activity, presence of activators and coenzymes, and influence of inhibitors and as poisons. And also the mechanism of enzyme catalyst. This is very important topic. We'll just go through it briefly in a very simple way of explanation. So many cavities are present on the colloidal particles of enzyme surface. So these cavities, they have got characteristic shape and they possess very active group like NH2COOH, SHOH, etc. So these are actually the active centers on the surface of the enzyme particles. So substrates, which are the molecules of the reactants, have complementary shape. They fit into these cavities just like a key fits into the lock. And also what happens is that on account of the presence of active group, an activated complex is formed which will then decomposes to yield to give the products. So enzyme catalyst reactions, which are very important, they are considered to proceed in two steps. That is, we look at the two steps in which they proceed. You can see in the figure, that is the first one, E plus S, and in middle you can see ES, and finally product E plus P. So you can see that the enzyme catalyst and substrate, it is getting fixed C to form the complex, and then you can see that the enzyme will get separated and the products are formed on the right hand. And this is the mechanism of the enzyme catalyzed reaction, which is very important, and you can easily understand the process from the figure. Now enzyme catalyzed reactions is considered to proceed like the firstly binding happens, that is enzyme will get binded to substrate, you get an activated complex ES, and then the ES will be decomposed to give E plus P. Activated complex is giving to form the giving the product by decomposition. And then we have got another important term coming up here, which is colloid. You all would be very familiar about the term colloid. What is a colloid? It is a heterogeneous system in which one substance is dispersed as fine particles to another substance called the dispersion medium. So this dispersed phase in colloids has many particles of single macromolecule like protein or synthetic polymer or an aggregate of so many atoms, ions or molecules, and these colloidal particles are large than simple molecules, but they can be suspended, so because they are small enough to be suspended in the medium. And we can classify colloids on the basis of mainly three things. Firstly, physical state of the dispersed phase and dispersion medium. Second, nature of the interaction between the phase and the medium. Finally, the types of particles of the dispersed phase. So firstly, we look at the classification based on nature of interaction between dispersed phase and dispersed medium. So for that, you should be knowing some important term like lyophilic colloids. So lyophilic means liquid loving. You know, colloid salts directly formed by mixing substances like gum with a suitable liquid, like it can be gum or gelatin, starch, rubber, etc. Liquid is the dispersion medium. These are called lyophilic salts. The important characteristic of these salts is that, you know, when you separate the dispersion medium from dispersed phase by evaporation or something, the salt again will be reconstituted. Simply you can remix with the dispersion medium. So because of that, we call these salts reversible salts, and these salts are quite stable and they are not easily coagulated. So something we have got very important to study in this context is gold number, which is not given detailed here, but it's important in the examination point of view. I'll give a simple trick regarding the gold number and how to find out the gold number and all that in another separate video. Now we have got something known as lyophilic colloids. So lyophilic means liquid hating. Lyophilic is liquid loving. Lyophilic means liquid hating. So mainly substances like metals, their sulfates, etc. When you simply mix it with the dispersion medium, they do not form the colloidal salt. But you can prepare it by special methods, like many methods are there already. We'll be discussing it again in some other unit after finishing this off. So these salts are called lyophilic salts. And they are readily coagulated when you add a small amount of electrolytes just by heating or shaking, and these are not stable because of that. So once precipitated, they do not give back the colloidal salt by simply adding it to the dispersion medium. So these are called irreversible. So I hope you understood the difference between lyophilic and lyophilic colloids. Then you can classify the colloid as multimolecular, macromolecular, and associative colloids. So what are multimolecular colloids? So on dissolution, many atoms or molecules of a substance will group together to form species with size in the colloidal range of 1 to 1000. So these species are called multimolecular colloids. So like gold salt, it contains particles of various sizes with many atoms. Sulfur salt also, it has thousands or more of S8 molecules. Now macromolecular colloids, it is a suitable solvent which forms a solution in which the size of the macromolecules is of colloidal range. So these are called macromolecular solids, and these are quite stable and resemble true solutions. And examples of naturally occurring macromolecules, starch, cellulose, proteins, enzymes and all that. And many man-made macromolecules are there like polythene, nylon, polystyrene, synthetic rubber and all that. We've got a third type like associated colloids known as micelles. So some substances at lower concentration, they behave like normal strong electrolytes, but when you go to higher concentration, they will show colloidal behavior because of the formation of aggregates. So these aggregates particles formed are known as micelles. These are also known as associated colloids, and the formation of micelles takes place only above a particular temperature. That temperature is called Kraft temperature, TK, and above that particular concentration, which is known as CMC or critical Michel concentration. So when you dilute this, colloids will come back to the individual ions. So surface active agents like soaps, synthetic detergents and all that they belong to this class of micelles. And for soaps, the CMC is 10 raised to minus 4 to 10 raised to minus 3 mole per liter, and these behave or these have got both lyophobic and lyophilic parts. So micelles contain as many as 100 molecules or more. And next we will see the mechanism of micelle formation by taking soap solutions as example. So what is soap? Soap is a sodium or potassium salt of higher fatty acid. You have studied this in earlier classes also, and it is represented in the form of RCOO minus, my negative part, and Na plus. That is sodium stearate, which is a major component of many bar soaps. So when you dissolve it in water, it dissociates into RCOO part will get dissociated, negative part, and Na ions. So RCOO has two parts. It has got a long hydrocarbon chain R, which is non-polar. We call it a tail, which is water repelling or hydrophobic. And the polar group COO, it is called polar ionic head, which is water loving or hydrophilic. So you can see a soap molecule here. Like you have got a long hydrocarbon chain, that is water repelling and known as the tail, and short ionic part, which is water attracting and Na plus. Then what happens is that RCOO ions, negative ions, which are present on the surface with the COO groups in water and hydrocarbon chains they stay away from it and they remain at the surface. But what happens is that at a critical Michel concentration, the anions are pulled into the bulk of the solution. Inside the solution, they aggregate or group themselves to form a spherical shape with the chains tail pointing towards the center of the sphere, and the COO part will point outward on the surface of the sphere, which is known as the ionic mixture. It contains as many as 100 such ions. So you can see that in the case of detergents also, sodium lauryl sulfate, the polar group is SO4 minus along with a long hydrocarbon chain. So here the mechanism is same as that of soaps. You can see that the stearate ion, you can see in the water surface, the tail end is pointing outwards now, and the negative ion part, arrangement of stearate ion at the low concentration of the soap, and the stearate ion inside the bulk of water at critical concentration. You can see all the ionic micelles, they are with COO negative ends are pointing outwards. Okay, so the structure is very important, and you get many questions normally for NEET exams as well as board exams from this concept. And with that, I am winding up this session, the part 3, and since this is a very big lesson and as well as very important one also, I have divided this into 5 parts, and we have already completed 3 parts, 2 more parts to go. So why I am not wasting time in between by engaging into simple meaningless talk is because already all would have finished off your portions in school. So those who are going to appear for NEET exam this year, you've got plenty to learn from class 11. You have to finish off everything and then learn for board exams and as well as for NEET also. It's a very hectic schedule. So I want to be very serious regarding the studies, and that is why I'm putting my comments off, because I don't want to entertain all of you into just simply talking. and also all the important concepts which you should know. I've just prepared a very easy and simple notes that I'm sure none of you will get any doubts from the preparations I've made. So it's all very easy. You just read it repeatedly, and only repeated revisions will help you. Just focus on your full concentration and mind into what you are reading. Revise everything, go through the questions, MCQs, and that itself is enough for doing the exams and for final last minute quick revisions, and finish off all the lessons which I've uploaded earlier, so that you can wait for the remaining lessons. I'll be uploading all the lessons from 11th class and 12th class one by one, finishing the difficult ones first. And don't forget to subscribe to my channel, share it with your friends, and like this. And also study, take notes, and focus well on your studies, because the next exam is going to come soon, so you won't be getting much time from now on. So with that, we'll wind up this session as well, and I'll be coming up with the next part at the earliest. And thanks for watching this video.